Hi, this lesson is all about one of the biggest volcanic eruptions of the 20th century, when Mt Pinatubo in the Philippines erupted in 1991. Now, you should, by now, have watched some of the background information on this eruption. If you haven't, you need to watch that before you go any further. Okay, if you have watched the video, what I'd like you to do now is press pause and have a go at question 13 on page 29 in your Theme 8 booklets, all about some of the geology behind the eruption of Pinatubo. See what you can work out. Okay then, let's have a look at some answers. I gave you a map to show the tectonic setting and another map showing the area close up around the Pinatubo crater where the volcanic hazards had done their thing. Crucially, in this eruption, there are two places marked on this map. You have Clark US Air Base and Subic, which was a big naval base for the US Navy. Because the Americans were so heavily involved, the United States Geological Survey had their volcanologists working on this eruption, along with the Filipinos, and that significantly improved the quality of predictions, saved a lot of lives. Anyway, the first question is all about the volcanic ash. You can see that it's distributed around the volcano, but it's not even. The problems that volcanic ash causes are many and varied. It's dreadful stuff. I've listed some of the potential hazards there. I'm sure you can perhaps think about more of them. It is a very, very dangerous hazard, yet one that perhaps a lot of people don't immediately associate as being one of the worst things to come out of a volcano. The second question was looking specifically at the ash to think about where it was. If we measure the distances, we see that Clark Air Base is about 15 kilometres from the crater. Subic Naval Base, about 32 kilometres from the crater, actually had the same thickness of ash. So why do you have these two places that are different distances from the volcano, both having the same thickness of ash being deposited? And the answer to that is the wind. The wind must have been blowing from the northeast to the southwest, blowing the ash towards the southwest, so we get a greater thickness being deposited further from the volcano. More ash is going southwest than manages to make it to the northeast. We then look at some of the other hazards. Pyroclastic flows here, you'll notice, are more confined to the area around the crater. The maximum they go is about 15 kilometres. Particularly spread out on the western side. Again, that could be a result of wind coming from the east. There's a few of them on the eastern side, but mostly seems to be on the west. If you look at where the lahars are, they're confined to narrow valleys, but they do travel a lot further, maybe up to 40 kilometres from the crater, lubricated by the water and confined into these fast flows at the bottom of the river valleys. For those of you that had to go at the digging deeper, you can see in figure 1 we've got a plate tectonic map that shows us the Manila Trench, which indicates that the Indo-Australian plate there on the left is being subducted underneath the Philippine plate to give us a plate margin, a convergent plate margin. Now, where we get convergent plate margin, we'll have subduction of oceanic crust. That subduction is going to create more silicic magma, which is more viscous, so therefore will trap more gas. Because it's oceanic crust that's going down, there's going to be a lot of water with it as well. That makes for much more explosive eruptions than would be the case if, say, we had a divergent plate margin. Okay, as we see a photo here of the crater at Pinatubo at sunset, we can see that the tectonic setting combined with some other conditions on the day created the set of hazards for the eruption of Pinatubo. It is, or it was, one of the biggest eruptions in the last 100 years. It can, of course, happen again. It's why it's so important for us to understand the geology of these places so we can understand the nature of hazards that can be caused. And perhaps, as was the case at Pinatubo, to come up with an effective prediction model which did help to save lives. Next time we need to start tying everything together. I'll see you then.